All right, welcome back. So we're gonna go through this really quickly. Basically, you should get down to the end here and realize if you're following the order of operations correctly, this is where you should have got stuck. And realize you can't take the square root of a negative number. Since you can't do that, you end up with no solution for this one. However, I went ahead and wrote in an example F where I just changed the sign of one of these values. So I changed this negative 11 to a positive 11. So that should change the sign right here to a positive 132. So let's go ahead and rewrite this problem. And let's actually get an answer, because I want to help you actually come up with an answer here. So 4 plus 132 is what you end up with here if we're looking at example F now, okay? So this is now still -6 down here, okay? So now let's solve this. So this part becomes -2 plus or minus the square root of 136 all over -6. Okay, so this is going to be a little complicated because something that I notice here just by looking at this, I can see that this is divisible by 4 because I know 36 is divisible by 4 and 100 is divisible by 4. So I'm going to use my calculator, figure out what that is. And the reason why 4 is so important is because remember when we have a number, sorry, I'm doing the math right now. So when we have a number inside the square root, that can be simplified by taking out a perfect square, which, why is 4 important? Well, because 4 is a perfect square. So I can remove a 4 from this, which means this problem is not simplified all the way down. We have to remember what we learned all the way back in chapter 6, that this can actually change to the square root of 4 times the square root of 34, okay? And then I can solve the square root of 4, because I know the square root of 4 is 2, times the square root of 34, -6. And now I examine 34. Can 34 be broken down any further? No, there's no perfect square that comes out of 34. Doesn't matter that it's even. That's not really what we're looking for. We're looking for can numbers like 1, well, we skip over 1 because that's not going to change anything. But can 4 come out of there? Can 9 come out of there? No. 16, no. 25. If you go down the list, you'll quickly run out and realize, yeah, there's no perfect square that comes out of this. So this is factored all the way down. However, here we also have some simplifying that can happen. Notice that the 6 isn't going to interact with this 34 here, but these 3 numbers can interact with each other. The biggest number that I can pull out of these 3 numbers is the number 2. So they all divide each other. So this is like simplifying a fraction. So this becomes -1 plus or minus 1 times square root of 34, which means it's just the square root of 34 all over -3. And that is my answer, right? Now you can see why using the quadratic formula was that's really the only way to solve this one. This one would be really hard to try and solve any other way. So this is the surefire method for solving problems like this, right? Just like if you get a no solution problem, it's really easy to see that when you use the quadratic formula, okay? So you're probably gonna end up using the quadratic formula a lot during this section. That's totally fine. We need more practice solving by using PEMDAS, right? So what I want you to do is we're just going to skip over the homework from the book because this is kind of a big section. So we're going to cut straight to the homework from practice 9.4 extension. And when you're doing this, something to keep in mind is you need to, for every single problem on there, use not just one, but 2 methods for every single problem on there, okay? So you're going to use 2 methods, And what I'm going to want you to do, because you're probably not going to have enough room on the paper, is use a scrap paper to do all your work, okay? So you're going to rewrite the problems on the scrap paper and solve it that way, because you're probably going to use multiple pieces of paper. Let me check the homework one more time, make sure I'm not missing any details before I let you go. But I think that's everything. Yeah, so if I'm looking at this, you use 2 different methods. Use your method of choice. Okay, so yeah, I think what I'll do is I might come back later and do, no, actually I feel like you can figure out how to do 13 and 14 on your own. But let's actually just follow the rules exactly on the paper. This is just going to be for numbers 1 through 4, okay? So for numbers 1 through 4, remember to use 2 different methods, and then for the rest of them, you can use just one method. But whatever method you do, you need to point out why you chose that method. So why did you choose that method? And you're going to use your notes to tell you why, right? So all the other methods are too difficult might be the reason why you use the quadratic formula. Factoring, you would use that method because the A value was equal to 1, and it was easy to tell what adds to make B and what multiplies to make C, right? So stuff like that. That's what you're going to explain in each of yours, okay? So I want you to try and use different methods for each of them. Try and really challenge yourself to use as many different types of methods as possible, okay? To get as much as practice as possible for the test, okay? All right, that's everything.